All right. So we got butane. Now butane is what we call, underneath it I want you to write straight chain alkane. Hey, what's going on?
I needed this.
Ah, you were the one.
Yeah. You gave it out Friday, right?
I guess, yeah. All right, good talk.
Thanks.
All right, straight chain. Why is it a straight chain? It's a straight chain of carbons. They use the word chain. Think of like chains, like links in a chain. That's what carbons are. So that's what these are. Okay, straight chain. Now, a branched alkane, I'm going to take the same number of C's and H's, so C4H10, and I'm going to rearrange it. And I'm going to put a branch on there. So, C4H10, write this again in your notes. This time I'm going to draw different. 1, 2, 3. I'm going to take this fourth carbon, and I'm not going to attach it over here. I'm going to put it in the middle. I'm going to hang it off the bottom, or the middle C here, going off the bottom. Both of them have the same general formula here, C4H10, but their structures are different. This thing is called a branched alkane. Still a hydrocarbon, just C's and H's, still nonpolar. Not a whole lot has changed. The properties do change. I'm going to talk a little bit more about that tomorrow. But still an alkane. But now the name changes. Why does the name change? Because the structure is different. So there's a couple of things here. This is called a molecular formula. We're going to write that down. This is called a structural formula. Structural formula is like the models. That's how you draw it, so it kind of looks like that in real life. Molecular is just the subscripts. In fact, let's write that here. This is the molecular formula. And then this is the structural formula. Okay. All right. So, just to be clear, I want you guys to do me a favor. How many bonds are in butane? Count them up to yourself. How many bonds are in butane? You know what? I don't. Where are all the big numbers? Reagan, what do you think?
Well, I mean, since each carbon has 4 bonds, it makes 16, but there's only 13 on there, I think.
Did you count them all?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
You counted all of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good job. How many bonds are over here?
It's the same.
Same. So that's the point. It has to be the same. Why?
It's the same molecular formula.
Same number of atoms. So this is what I'm trying to show you. I'm going very slow today, trying to be very simple with my explanation, so you really understand the basics, and then it makes life a lot easier. Typically, when we put these together, we put the big sticks between the carbons, so that's these bonds here, and then little ones with the C's and the H's. It makes it look better. It's easier to see what's going on. So hang with me for a second. Okay. So this is butane. Now, yes, in real life, actually, it has this like zigzag type shape to it on paper and on regions. In organic books, I'll show you my big fat organic book, just to show you how much is in there. This is a huge part of chemistry, this topic, but we draw straight lines. Straight chain, straight line. So yes, it looks kind of zigzag, but this and that are the exact same thing. So if I was to count the sticks, it would still be the same as the dashes. Okay, good. Now, branched means I'm taking, let's say, this one off, right? So if I take this one off, and I'm going to put it down here. now, this is this. All I did was rearrange the same number of atoms, therefore, same number of bonds. I feel like this one is not. It's like a little short one, or short, long one. Anyways. So, what am I trying to teach you? That if you take a straight chain and just reorganize it, kind of reconfigure it, I always think of Mr. Potato Head. Why? Right. Put them together like the way he's supposed to look, and then take them apart and put his eyes where his nose is and his ears where his feet are. You can do whatever you want, right? So it's the same thing. You can rearrange these things so they look different, but that doesn't change the number of atoms. I'm really trying to stress that. Hopefully that makes sense. All right. This has a different name. This is not butane. Butane is a straight chain. Okay. Here's how we do it. So I'm going to show you the steps. Pay attention very closely. All right, and you're going to learn how to name this thing. All right, so I'm just going to erase everything and rewrite it so we can just focus on one thing. All right. All right, so when we are naming these things, here's how we do it. All right, so first thing you got to learn, I want you to write this in your notes. A CH3 group, it's called a CH3 group, is called methyl. That's what a CH3 is called, methyl. Another way to write that would be C with 3 H's coming off. I want you to put all that in your notes. So CH3 and this are the exact same thing. That's the first thing I'm going to teach you. That doesn't make any sense, not yet, it will. Okay, so a CH3, so a C with 3 H's is called a methyl group. That's what it's called, a methyl group. This thing is called a substituent. A substituent. I'll put that down there. A substituent. Does anyone know what the word substituent means in real life? Like, not in chemistry. A substituent is usually something, a small part of something bigger. So, like large companies have like satellite offices. I don't know if that makes sense to you either. Like a satellite, something small that orbits Earth. Earth's the big thing, and then something small off of it. It's called satellite. The substituent is a small piece, kind of like our district's very small. But bigger school districts have like elementary schools spread out. Maybe they have an elementary school over here, and then over here, and they have a middle school here, and their high school's here, and it's like separated by miles. Ours is right here. But a substituent of the school district. So like the high school building would be a substituent of the entire district. The elementary would be a substituent of the entire district. So a substituent is a small piece of something larger. So that is our branch. So what we're going to do here, and we're going to practice this today and tomorrow, is when you have a structure with a branch, we have to first name that branch. So here's how we do this. All right, so you look at this structure, and this I had to tell you first, but that's not actually the first thing we do. Here's how we do it. You look at this structure, and I want you to count the longest chain of connected carbons. So if I look at this, what I mean is, how many carbons can you count in a row until you have to stop counting? So if I start here, I can go 1, 2, 3, and then I run out of carbons. I can start here and go 1, 2, 3. I can start here and go 1, 2, 3. I can start here and go 1, 2, 3. I can start here and go 1, 2, 3. I can start here and go 1, 2, 3. What's the same result every time? 3. The longest connected chain of carbons is 3. So I need you to be able to see that. I hope you're understanding what I'm saying. That if you have a alkane drawn on paper, can you count the longest chain of connected carbons? In this case, 3 is the longest. Let me just give you another quick example. Don't write this. What if that was my carbon structure? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No matter how I count this, 5 is the longest chain of connected carbons. This only has 3. Am I making some sense? I know it's new. Look, do you understand 3 is the longest chain here, is what I'm trying to get at. Okay, good. So that's the first step. And obviously you're going to practice, right? So if you don't get the first example, don't stress out. We're going to practice. All right. Here's the rule. Count the longest chain and you put a box around it. Go ahead, do that. So if you have to redraw this, go ahead. Redraw it if you need to. Count the longest chain of carbons, connected carbons, put a box around it. Now, the old days, when I first started teaching, I used to like write all the rules on the board and like try and have the kids memorize the rules. I don't do any of that anymore. I don't give notes on it. I just practice. We just do practice and practice and practice, and it helps. It's a lot better than writing all the notes and writing the rules. So I'm going to give you the rules out loud and show you how to do it, and then we're just going to practice. So you will pick it up, I promise. All right, so 1, 2, 3, there's a box. All right, anything outside the box, you circle. Anything outside the box, you circle. All right, so now you have to name the box and name the circle. Then you put it all together. That's it. That's the whole show. So let me recap. You see the structure, you count the longest chain of connected carbons, you put a box around it. Anything outside that box, you circle it. Now we have to name inside the box. So, inside the box, ignore this carbon is here. Forget that's even there. 1, 2, 3. What's the prefix for 3? Pro. Inside the box, single bond, double bond, triple bond.
Single.
All single. So what is it? Alkane, alkene, or alkyne? Alkane. So inside the box, what do we call it? Propane. C3, right? 3 carbons, all single bonds. So inside this box, that's propane. All right, outside the box is a circle. This thing, write this in your notes, is called a substituent. A branch is a substituent. The propane is our tree trunk, called the parent chain, the carbon backbone, the main chain. You're going to hear me say a lot of different things. So there's our main chain. Branching off of it, the smaller piece of the bigger picture, that's our substituent, like one building out of an entire school district. This is one part. It's a CH3. That's called a methyl group. So this is called methyl. Kind of like methane, but it's not methane. I'll explain that in a second. So, I know this is weird. You've probably never learned anything like this before. Don't worry. You will get it by the time you leave, because we're going to do a couple more practice problems. All right. 1, 2, 3, that's where propane comes from. 1 carbon outside the box, we circle it. 1 carbon with 3 H's is called methyl. That's something you're going to memorize. You'll just get it. It'll just happen. All right. Last thing we need to do is you have to tell whoever's going to, let me rephrase that. The goal of naming this thing is so someone else can draw it. So you're going to name this so that if I said, okay, Sean, draw blah, 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 he'll be able to draw something that looks just like this. So that's the goal of naming. So now there's one more thing we have to do. We have to tell the person what carbon this methyl is attached to. Because the branch isn't on this carbon, and it isn't on this carbon, it's on that carbon. So we have to number our parent chain. When we number our parent chain, this is 1, this is 2, and this is 3. Go ahead, write that right in your notes. Carbon 1, carbon 2, carbon 3. So now I know the methyl group is attached to the second carbon. So the name of this structure is, so the moment we're all waiting for, 2-methyl-propane. So now if I said, Sean, draw 2-methyl-propane, he could do it. Right, Sean? So the goal today, we only got a little bit of time, we're going to do 2 more examples, is to learn how to name these. Tomorrow, we're going to do it in reverse. I'll give you the name, you're going to try and draw it. Does anyone want to ask a question before I move on?
Can we go through another one kind of slow?
Yep. Actually, here we go. Draw this. 1, 2, 3, 4, and then we'll put carbon here. draw that. We'll do this one slow, and then I'll give you one more. You can do it on your own. By the way, don't write this, just pay attention. That and that are the same thing. I'll show you why. Anyone want to tell us while I'm messing around with this thing? How come those are the same thing? How can they possibly be the same thing? Yeah. Okay. So here's this one. Don't break. So here's this one. You do it. Okay? 4 carbons in a straight chain, and then a branch coming off down here. Here's this one. What did I do? Just flipped it. So whether you look at it, so if you're looking at it from where you're sitting, it looks like this. My perspective, it looks like that. That make sense? Bella? Okay. Alright, good. Just want to make sure. Alright, let's name it. What's the longest chain of connected carbons? 4. Put a box around it. And don't sit there and humor me. Do it. Put a box around it. Like, don't humor me in your mind. Be like, oh, okay, there's a box. No, do it. Write it down. What do we do with anything outside the box? Circle it. Next step, what do we name? In the box, which is butane. 1, 2, 3, 4. There's bute, all single bonds. Ane. What do we call the CH3? That's a methyl group. Now, there's one of 2 ways you can number the carbon chain. You can number this from left to right or from right to left. So in other words, you could say 1, 2, 3, 4, so that's carbon number 2. Or you could say 1, 2, 3, 4. Right? So like, look at this one. If we number both of these from left to right, which is what I know you want to do, 1, 2, 3, 4, go ahead and write that down. That is correct. If we number this from left to right, it's wrong.
It's gotta go down.
The right way to number these, so this is the last part that I didn't teach with the other example. The number that this substituent is attached to must be the lowest number possible. So in other words, you could number this 1, 2, 3, 4, making this carbon number 3. That's not correct. Your organic gods say don't do that. So if there's 2 ways to number this, you need to go for the low, is what I say. Go for the low. So this is carbon number 2, not carbon number 3. So if we numbered this 1, 2, 3, 4, that's wrong. Instead, it would be 1, 2, 3, 4. So this has to be number 2, not number 3. Go for the low. All right. What's the name? 2-methylbutane. 2-methylbutane. And this weird little dash that I keep putting in front, that's technically how you're supposed to do it. If you forget that, it's not the end of the world. But that's how we do it. 2-methylbutane. And I'm out of time like this. All right. Homework. Do tomorrow. Don't forget, what else do you have? You have a review sheet due tomorrow, too.
I got to school anytime this week.
Today.
or tomorrow.
Today. Today is more better. I'm not sure you're ready for this.
We're not.
Just part of this interruption, due to the weather, here's the updated indoor practice schedule for baseball and softball. Varsity girls will be 3:30 to 4:45 in the gym. Varsity boys 4:45 to 6 in the gym. JV girls 6 to 7:15 in the gym. Mod girls 7:15 to 8:30 in the gym.
No homework.